Okay, so for B, we have 2x plus 3 greater or equal to 4. So if we define it in this way, if it is greater or equal to 4, this means that we have two pieces. So we have 2x plus 3 less than -4 and 2x plus 3 greater or equal to +4. So we have less or equal to. That's the more reason. So for this one, we cannot define it in the way we have defined this because of the greater or equal to. Okay, so we are taking, because what this means, for example, let's take numbers. Say -4 is here and 4 is here. The modulus gives a positive number. So we have 2x plus 3. If we pick a number, so suppose we had sorted out everything with this, and you pick a number, let's say you pick -5. You place it in here. You get 2 by -5 plus 3, and this is -10 plus 3, which is -7. Now -7 in the modulus will come out as 7, and 7 is greater than 4. If we pick 5, then we have 2 by 5 plus 3, which is 13. In the modulus, 13 is still positive. It is greater than 4. But if you pick a number in between this -4 and 4, if you pick, say, 0, you get 2 by 0 plus 3, which is equal to 3. And 3 is not greater than 4. So that's why we are defining it in that way, so that the inequality is not disturbed. So we now solve. So the piece on the left is giving us 2x less or equal to -4 minus 3 when we take this other side. And the piece on the right is giving us 2x greater or equal to 4 minus 3. So that we get 2x less or equal to -7 and 2x greater or equal to 1. So we have x less or equal to -7 over 2 and x greater or equal to 1 over 2. Okay, so I'm going to use or because it's not the intersection. So I'm just saying we have this interval, the inequality to be satisfied, or we can use the other interval, the inequality to still be satisfied. So now we have two intervals, this interval and also that interval. So our solution set is x, a real number, such that x is in -infinite, comma, -7 over 2 union half, comma, +infinite. If this is too much for you, you just say the solution set is -infinite, comma, -7 over 2 union half, comma, infinite. For as long as you include the boundaries. That's why I'm doing this. Because we have greater or equal, so we need to include the boundaries. So do you have any question? You can raise up your hand and then I'll allow you to talk. Okay, so there's no question. We can move on. So we'll do C. C, we have x plus 1 over x minus 2 less than 5. So this we define the same way we defined the first one. So we're going to have negative 5 less than x plus 1 over x minus 2 less than positive 5. Now, when we have variables in the denominator, we do not cross multiply because we don't know. The reason why we don't cross multiply is because we don't know the sign of that x minus 2. Okay, so the reason why we do not cross multiply is because we don't know the sign of this. And we must be very much aware that whenever we divide or multiply by a negative, the inequality will change. Now, because we don't know the sign of that variable down there, we cannot cross multiply because we don't know whether to change the inequality or not to. So for that reason, we just have to break this into two pieces. Say this is less than x plus 1, x minus 2, and this is less than 5. And then we solve this as two pieces, then we intersect the solutions that we find. So the first one, negative 5 minus x plus 1 over x minus 2 less than 0. If we take this the other side. If you also take 5 the other side, the other interval also will behave the same. So it will be x plus 1 over x minus 2 minus 5 is less than 0. So let's solve this one first, then we'll go to the other one. So we find the common denominator, x minus 2. 1 in x minus 2 will get negative 5x plus 10. Then the other one will give us minus x minus 1 is less than 0. Because we're expanding by the negative, so that we get negative 6x plus 9 over x minus 2 less than 0. Then from there we get what we call the critical values. The critical values do not have any sign when you substitute them in there. It's either your expression becomes undefined or it becomes 0. Okay. So negative 6x plus 9 is equal to 0 implies that x is equal to 3 over 2. And x minus 2 is equal to 0 implies that x is equal to 2. And then you use, so you can use a number line, you can use a table. I like using the table. So we'll have negative. So the testing table will have 3/2, and we'll have 2. And then I block here. I'm using this as my boundaries. And then I'll pick a number that is less than. I'll pick a number that is less than 3/2. I can pick 0 in this case. Let me just differentiate. So I can pick 0 here. And then I can pick 3 here. And then to find the middle number, 3/2 and 2, we can add them. And then after that, we'll divide by 2. So when we add them, we get 7/2. Then we divide by 2, so it becomes 7/4. So 7/4 is in between. We have this. Then from there, we now pick negative 6x plus 9 and x minus 2. So we now want to test using the number that we have picked. Our interest is in the signs that are coming here, so that which will make this inequality be satisfied. Okay, so let's test now. So if we get 0 and substitute in negative 6x plus 9, we're going to get positive 9. So it will be positive. If we get 0 and substitute in x minus 2, we'll get negative 2, which is negative. When you get your quotient, the quotient is negative 6x plus 9 over x minus 2. So if the top one is positive, the down one is negative, then we know we have a negative number. When you substitute 7/2, we'll have negative 6, 7/4, I mean, plus 9. This is 3, 2 down. When you multiply, get negative 21/2 plus 9. But this number is less than 0, so it will be negative. If we substitute 7/4, we'll have 7/4 minus 2. This is 7 minus 8/4, which is negative 1/4. So we have negative. So if we have negative over negative, it becomes plus. If we substitute 3 in negative 6x plus 9, we are going to get a negative number. If we substitute 3 on x minus 2, you get 1, which is positive. If you multiply this, you have a negative number, like that. Then we want where the expression is less than 0. So we'll go where the expression is less than 0. And those parts are this section and this section. So our solution set for this interval is going to be negative infinite all the way up to 3/2, close, union, 2 up to positive infinity. That will be our solution set for this piece. So from there, we go to the remaining piece, this one, and do the same. So we have over 1 there. So x minus 2, x plus 1 minus 5x plus 10 must be less than 0. This is negative 4x plus 11/x minus 2 less than 0. Again, we get the critical values, and this will be negative 4x plus 1 should be 0, implying that x is equal to 11 over 4. And the other one, x minus 2 is equal to 0, implying that x is equal to 2. So we make a table again. So we have 2, we have 11 over 4. So we draw our lines. And then, so here I'll put negative 4x plus 11. Here I'll put x minus 2. And then we'll have negative 4x plus 11 over x minus 2. Okay. So we now pick our numbers again. The number that is less than 2, we can pick 0. A number in above 11 over 4, we can pick 5. A number between 2 and 11 over 4, we can add this. 2 plus 11 over 4, we get 19 over 4. Then you divide it by 2, it becomes 19 over 8. And then we test again. When we bring 0 here, we'll get a positive number. When we bring 0 here, we'll get a negative number. So the quotient will be negative. When we bring 19 over 8, we have negative 4, 19 over 8 plus 11. This is 4 there, 1, 4 here, 2. So negative 19 over 2 plus 11 is positive. Then we also have so are these questions, what are these arrows for? All right. So if we add this, you get negative 19 plus 22 over 2, and this is positive. So the product okay, so I've gone to the next one. Okay, that one is negative. Then the other one is 19 over 8 minus 2. This is 19 minus 16 over 8. So it's positive, yes. So the product here is going to be positive. When we go to 5, we have negative there, positive, negative. The interest is that our inequality must be less than 0. Again, so the solution set for this part is going to be negative infinity all the way up to 2 union 11 over 4 all the way up to infinity. Now we have two solution sets, so we need to get their intersection for us to form the final solution set. So the intersection of negative infinity to 3 over 2 union 2 comma infinity, this intersection negative infinity to 2 union 11 over 4 to infinity. So this is going to be, how do we intersect intervals? So between this interval here and this one, on the left we pick the largest. Now negative infinity and infinity, they are all the same. So you pick that piece. Then between 3 over 2 and 2, you pick the smallest. So we pick 3 over 2 union. Between these 2 and this 11 over 4, you pick the biggest, which is 11 over 4. and then infinity, they are the same. So this is our final solution set. So do we have any question? Do we have any question? So if you have a question, Zulu Robert, you can unmute and then you ask. Robert, I can't get you. Okay, do you have any other question from inside as you wait for Robert to pick up?
Yes, asking about when.
Sam,
Yes.
are we getting the intersection of two sets or the union?
The intersection of two
Like,
sets.
okay.
So because
All
of
right,
this, we get the intersection. The other case, we got the union because the inequality was like that. So in this case, we want the part that satisfies both.
Sorry, I didn't get you clearly. What's the reason again for getting the intersection and the other one getting the union?
So for the intersection, we want both intervals. So whatever satisfies this interval must also satisfy this interval.
Okay.
And the other one where I got the union, we just wanted to have the inequality satisfied either by using this or by using that. So I can pick another question.
Yes, pick another question.
So I will now give a hint on D, n plus 2 over n greater or equal to 3. So this one you follow what we did in B, where you say n plus 2 over n is greater or equal to 3, or n plus 2 over n is less or equal to -3. The solving will be the same as what we are doing in the previous question in this one, except that when picking a solution, we'll pick following this pattern where I'm getting the union and not the intersection. So here I'm just giving a guidance. You should be able to finish. Then for E, we have x plus 6 less than x minus 2. Here, the best way is to define this using the square method. Because we know that we can define this as this. So whatever is in the modulus, if we square it and get its square root, then we'll get what we're looking for. And then if we square this, you also square on the right, then you have x plus 6 squared to be less than x minus 6 minus 2 squared. And then you should be able to finish up this because it will be 12x plus 36 less than x squared minus 4x plus 4, so that this and this cancels, and then you have 12 plus 4, that will be 16x less than, this goes the other side, 4 minus 36, you get negative 32. So you divide by 16, divide by 16, so you have x is less than negative 32 over 16, implying that x is less than negative 2. That would be a solution for that part. Jojo.
Yes, sir. I just wanted to clarify why are we getting the union in D when in the previous example we also had less or equal to, but we got the intersection.
In the previous example, we had less. In this one, we had less.
Okay.
The direction of this matters. So here, it was less the constant. But here, it's greater the constant.
All right.
So question D follows B, where it's greater the constant. So greater or equal to. So for the greater or equal to part, we just take care of it when getting the boundaries. We include the boundaries, but if it's just greater, we don't include the boundaries.
All right. Thank you, sir.
All right. And you also need to note that if one of the boundaries are coming from the denominator. Okay, so let me check. I think we had boundaries coming from the denominator. Okay, except all the times we had boundaries from the denominator, we had only less or equal to. So if in this question, we had a less or equal to here, we would wish to include the boundaries, but not the one coming from the denominator. Because if we include it, then our function will be undefined at that point. Our inequality will be undefined. So to avoid that, we leave the boundary coming from the denominator. Okay, so because of the Zoom plan that we are using, we'll have to log out and log back. We're in the last minute of the 40 minutes. So when you log out, you quickly log back because the class is continuing. So we need to finish this fellowship today. Then over the video, someone asked that, are you going to post the video? So to make the content not that much in terms of MBs, I squeeze it and post it on my YouTube channel. Then I post it in the group. So you follow it up there and then get it.
All right.
Okay. So let's log out and log back.